In this video, we're going to have a look at how we find the area of a triangle when we don't have its perpendicular height. So I'm going to show you where the rule comes from first of all. If you don't want to know that, you can fast forward through that and just go straight to the examples. So what we're going to do is work out how we determine that area A of a triangle without knowing its perpendicular height. So let's start off with a triangle and label A, B and C. And if we know that, then the side opposite the angle A is little a, side opposite B is little b, or lowercase b, and the one opposite C is, or angle C, is lowercase c. So I've just gone and labelled my triangle. What we're now going to do is drop in our perpendicular height. Now I know we're going to look at how we find without its perpendicular height, but we're going to show where the rule comes from first. And then that perpendicular height is going to meet at D. And what we're going to now do is we have a look, or we already know that the area of a triangle is half the base times height. So half times the base times the height, and that's its area, and that's what we use to find it. But we're going to have a look at a different rule when we don't have this perpendicular height. So we're going to have a look at the triangle BCD, which is this one here. And we're going to use some right angle trig in that in a moment. So I'm going to cover up the other part of the diagram so we don't get confused with that. And we're going to have a look at the sine of angle C. And sine is opposite over hypotenuse, so we get H over A. So I'll go through that part again. We're now looking in this right angle triangle here. We're finding the sine of this angle, which is opposite over hypotenuse. What I'm going to now do is rearrange that to make H equals. So multiply both sides by A, and I have H equals A sine C. And normally we're used to writing the H first, but it was okay to leave it in that format. Now that we've done that, what we're going to do is we're going to substitute this H value back into our original rule, so we no longer have a H there. So replace or substitute, whichever word you're used to. And we're going to take that original rule, half times base times height, and replace the H with A sine C. So wherever the H was, I've replaced it with A sine C because that's what we came up with before. And I'm just going to rearrange that because normally we have our pronumerals in alphabetical order. So our rule A equals a half AB sine C. So that's the rule we're going to use once we no longer have that vertical height. So let's go back and have a look at the original triangle there. That's what we started with. Let's get rid of that point D and its vertical height. So now if I want to find the area of that particular triangle, what I now want is two sides and what we call the included angle. It's the angle between the two known sides. So there's our rule. Area of the triangle is a half times the two sides multiplied by the sine of the included angle there. Just be careful though, because if I've got these two sides, if I'm given those two sides, this is not the included angle. That will be the included angle up there. So make sure that when you're using this rule, it's the two sides and the included angle. Alright, so let's have a look at a couple of examples. So our first example, we're going to calculate the area of this triangle, correct to two decimal places. And you'll notice that we're actually given three sides in this example, but we know we only need two sides and the included angle. So that's the angle between two of the sides. So there's our angle, and we're going to use this rule, half AB sine C. So there's our angle, and there are our two sides that make that the included angle. So once we know that, we can then substitute those in. So a half times the two sides times the sine of the included angle. So we're not using the 9 in this situation. Do that on our calculator, and again we want to round that off correct to two decimal places. So we get the area is approximately 36.23 square meters. So once we know the rule, substitute in, and then we can get our answer straight away. If we have a look at another example, this time no diagram is drawn. A little bit more complex this one. A triangle has an angle of 108 degrees 37 minutes, with one arm of the angle being 15 kilometers in length. If the area of the triangle is 135 square kilometers, find the length of the other arm of this angle correct to the nearest kilometer. So I think we might start off with doing a diagram. So here's a triangle, and there's an angle of 108 degrees 37 minutes, as it says in the question. The next part says one of the arms is 15 kilometers. We're also told that the area is 135 square kilometers, so this enclosed area here, we already know. We want to find the other arm length. Remembering it's the included angle, it's that part of the angle, and they're both arms or raised, depending on which way you're used to. So, there are two sides and an included angle. We can see that, two sides and the included angle. So there's our rule for area. And again, once we've got that rule, we'll substitute in what we know. This time we know that the area is 135. A half times one of the sides times, I labelled the second side V, and then times the sine of the angle, the included angle. Well, we can take a few different options here. We can simplify some of the expressions first, but what I might do is all of these components here are multiplying the V. So the opposite of multiplying is division. So to eliminate the right-hand side, we're going to divide both sides by those terms. So let's do that. Let's divide both sides by all of those terms there, and we get 135 over those terms to get V by itself. And now it's a straight calculation, just being careful with the use of your calculator. Make sure that you get 18.99, etc. And then again, we want to the nearest kilometre, so let's go and round that off, and that's approximately 19 kilometres. So I hope you've actually found this video useful, but what you now need to do is practice, and then practice again, and then practice some more. And the more you do, the easier it will become, and the less chance you will have of making mistakes. So I hope you found this video useful, and now just go and practice your techniques with that.